another formula. We're going to find the sum of the exterior angles. And there are some things on the worksheet that aren't written in that we have to write in, because some of these things only apply in certain situations. So are you guys ready yet? Do you know where to find it? Okay. I'm going to draw a polygon. It says the sum of the measures of the exterior angles in a polygon, which doesn't really say. I'm just going to draw any old polygon. And make sure you understand what an exterior angle is. If you can't see, please let me know. This is an interior angle. I'm going to call that I. So when I use the letter I, that's the measure of the interior angle. What's the question, TJ? Your calculator? Yeah, you need to be on the lesson first. We may be out of batteries. Yep, we're out of batteries. Sorry. And we have at each vertex, and the question came up in the last class, what's the vertex? The vertex is where the sides meet. So this side and this side, they're consecutive sides, they meet right there. That's a vertex. Okay, Sydney? That's a vertex. Well, at each vertex, you can extend the side. Yeah, I only want to extend one of the sides at each vertex, not all of them or both of them. And that's called an exterior angle. It's the angle outside the polygon. So E, I'm going to let that stand for the measure of an exterior angle. We're going to have all these nice little formulas I have written on the board. Maybe I should write them on the smartboard as well. But right now I want them there always when we're working on the problems. You could draw, if you wanted to, you could draw the other exterior angle. And when I draw these, what's true about these angles? When I have two intersecting lines, these angles are congruent because what are they called? Vertical. Do you see the V there and the V there? They form V's, so those are vertical angles. So that each vertex, there are two exterior angles, but I'm only going to count one of them. So I'm only going to do one of these sides there. So that's a little confusing right there. There's also something else that's interesting about the measure of the exterior angle and the measure of the interior angle. They form what? A linear pair. So I and E, I should put angle signs in there, form a linear pair. And what we learn in geometry is how to think deductively. If I have a linear pair, what's true if I add up their measures? It equals 180. So we're starting with something we know and drawing a conclusion. Okay, so that's one of my formulas up on the board, right there. The measure of the interior plus the exterior is 180. And we have another formula from yesterday. What was true about the sum of the interior angles? Do you remember the formula? If you forget, you can always figure it out. How many triangles can I draw if I have a quadrilateral? How many triangles are there? 2. If I now have a pentagon, how many triangles can I draw? N equals 5, so this is 3. What's the relationship between these numbers? N minus 2. Okay, I didn't want to go through that whole process again. But it's the number of vertices minus 2 times 180. That's another formula I put on the board. Simple formulas. However, applying them is not always simple. Okay, so we did yesterday the sum of the interior. We're talking about exterior angles today, and we know that the interior angle plus the exterior angle adds up to 180. So now let's do the next problem. We have a large pentagon. You've drawn it. This happens to be a regular pentagon. It doesn't have to be to do this, by the way. That's what's kind of interesting about it. So here's my interior angle, and here's my exterior angle. And it says, now label all of the interior angles using the formula we developed yesterday. So the sum of the interior angles is what? Jesus, are you picking this up? It's n minus 2 times 180. Well, what's n here? 5. Now, I want you to be able to read this. Let's say you're absent today. I'm not just going to write down 3 times 180 or 540 because I know that's what the number is. I want you to be able to read it. So f sub I is equal to 5 minus 2 times 180. This is clear to the reader that I'm going to take the 5, subtract the 2, and I'm going to get the 3 times 180, and the rest is arithmetic. That's 540. My focus is not in the arithmetic. Although if we don't have the arithmetic right, I'm not going to be able to get the rest of the problems right. That's what they all add up to. Oh, I guess this is a regular pentagon. Read the directions. So sometimes you have to read. It is a regular pentagon, so how big is each interior angle? But this will be true for all pentagons. They're the same. So what's an interior angle equal to? It's the sum of the interior angles divided by, in this case, 5. So you're going to take 540 and divide by 5. And what are we going to get? You can do that one in your head. 5 goes into 5 how many times? Once. 5 does not divide into 4, but 5 goes into 40. How big? 8. So it's 108. They're all 108 because it was a regular pentagon. I need to read my problems. Then I can find the exterior angle because they form a linear pair. How big is the exterior angle then? You subtract it, and that's why you want a calculator. 180 minus 108, because I found that the homework without the calculator got to be very tedious. It's 72. And each one of them is 72, because we're only going to count one exterior angle at each vertex. So what are the sum? What do they all add up to? How many 72s are there? How many vertices are there? There's 5 of them. That multiplication is pretty easy. What's that going to give us? 5 times 2 is 10. So it's 360. Now, if there's not enough room, you pinch the screen. Make it bigger. I always sometimes forget to do that myself. So the sum of the exterior angles in a pentagon is 360 degrees. What about a square? We'll go on to the next sheet in a second. What about a square? What are the interior angles? We all know this. They're 90, right? And then, if the interior angle is 90, what's the exterior angle? 90. Okay, I have no idea what that is. Okay. How many of those are there? 4. So 4 times 90 is 360. Well, that's kind of interesting. That's a good question. Is that the same for all the polygons? Well, let's look at a hexagon. Okay, there's the workspace. You could have done it there. But let's do the hexagon. Now, I do so much with hexagons, I know what the interior angles are. This is a regular hexagon. But the sum of the exterior angles is always the same if it's regular or not. It makes no difference. So here's one thing that's missing. It should say regular hexagon. Okay, so let's find out what do all the interior angles add up to be. Well, it's n minus 2 times 180. What's n? Okay, you guys did a really good job. Well, no, I haven't graded this class. But my other class did a really good job on this part. So it's 6 minus 2 times 180. And you know what? You clearly tell me what I want to do. If I multiply it wrong, but I can still see that I knew what to do. We just made an arithmetic error. That's different than not understanding. So 4 times 180 is how many degrees? 720. Now, so 720 degrees for all 6 of these angles. What's one of them then? What are you going to do with the 720 and the 6? Yeah, you're going to divide. You guys know how big that is? 120, right? I know this because I know a lot about hexagons. So that's 120. That's 120. They're all 120. So what's the measure of the exterior? PJ, what's the exterior angle? Why is your iPad closed? It's 60, but you should have your iPad open. If you're out of charge, you can get some paper. Because I have an external charger. Okay, how many exterior angles do we have? It's a hexagon. 6. So if we add them all up, because it's a regular hexagon, we get 360. It's the same. Well, that's not proof. But let's do a proof. Yes. Okay, so let's see if it really is. Okay, ready to switch pages? Okay, here's a little informal. We have 2 proofs today. Okay, Zach? Cole? Here's a little proof. For any polygon, we have a linear pair at each vertex. Now, this doesn't matter if it's regular or not. So here's the external, here's the internal. And how many degrees in a linear pair? What's I plus E? That's 180. Okay. So I know I have a hexagon here, but let's say we have an n-gon, any number of sides. So how many degrees will they all add up to? Each of these vertex, each linear pairs. So it's 180 times each linear pair, and there's n of them, right? Make sense? Now, that gives me everything. That's the only problem. I get E plus I. I get all of these, and I don't want all of that. I just want the exterior. So we're going to subtract off from 180n the sum of the interior. What's the sum of the interior? What's that formula? It's behind me on the board. No, interior. Right here. N minus 2 times 180. Well, let's do the algebra. So we don't have that much algebra in this class. We do have a little bit. It's more thinking and puzzles. So it's 180n, and then I'm going to distribute, so it's minus 180n. Now, what's the sign going to be? Because everybody makes this mistake. I have a negative and a negative, so it will become positive. Plus, and 2 times 180 is 360. What happens to the 180n and the 180n? They give you 0, right? So there it is. Doesn't matter how many sides. They always add up to 360. So that's my other formula right here. The sum of the exterior angles is 360. And I call it S sub E, yes. And that's my conjecture. So that's 360 degrees. Interesting, because the interiors don't. Interiors are all different, depending on how many sides you have. But the exterior, I don't care what you have. How about an equilateral triangle? I'm just going to take a regular one. It's not proof. If it's equilateral, how big are all those angles? We should know that. They're 60, right? Do we all know that? Yeah. Okay. And what's the X? I can't remember writing. What are the exterior angles? 120. And how many are there in a triangle? Do I get 360? Yeah. It's not proof, but it gives you the idea. Okay. I think we have a problem next. Let's try a problem. Oh, yeah, we have a couple problems, and then we have a diagram. How many sides does a regular polygon have if each exterior angle is 36 degrees? See, that's where the things get to be harder. If you have a regular polygon, the sum of the exterior angles is 360, but there's another way to get the sum of the exterior angles. What's true about all the exterior angles? They're all congruent, right? Here's your exterior angle. How many are there? Cole? If this isn't, I don't know how many sides. We'll call it an n-gon. If there were 6 sides, it'd be what? 6 times E. That would give me the sum of the exterior angles. So if I have n of them, I'm going to have, there's another way to calculate the sum of the exterior angles. I take the number of vertices I have times the measure of the exterior angle. If I combine these 2 equations, then I get this one. And this is the one you're going to have to know. The number of vertices or sides times the measure of the exterior angle is 360. And I can work with that algebraically. I can solve for the exterior angle. It's 360 divided by n. Or I can solve for n. The number of sides is 360 degrees divided by the measure of the exterior angle. And again, I put that on the board over here. Notice I put this under regular. It's only true for regular polygons. What's regular? Forgot to review that. Do we know? All, it's equilateral. That's one. There's two parts to it. And it's equiangular. You got to know the vocabulary. If you don't know the vocabulary, you will be lost. Like we're getting feedback from another room. This only works for regular ones when all the exterior angles are the same. Okay, so now, no, will not work for an equilateral that's not equiangular. It's got to be both. That's a very good question. So if I have an exterior angle of 36 degrees, I could work with the n minus 2 times 180. That's just harder. It's always easier to work with the exterior because to find the number of sides, I just take 360 and divide by the 36 degrees. And how many sides is that? 10. And what's that called if it's 10-sided? A pentagon is correct, but we have a special name. No, it's just a decagon. Think of a decade. Decade is 10 years. A dodecagon is 10 plus 2. Okay, let's look at the second one. How many sides does a regular polygon have if each interior angle is 144? Well, if I don't know what to do, I'm going to draw a little picture because I don't know what to do. This is 144. I could work with this formula, which is much harder to work with, or I could work with the exterior angle. How big is the exterior angle then? 36. We just did that problem, didn't we? Yep. The number of sides is equal to 360 divided by the measure of the exterior angle. So n equals 10. So still a decagon. So when I do these problems, I always work with the exterior angle because that's easier because I can use these little formulas. To do it with the S of I is much harder. I'm not even going to give you an example of it because it's just that much harder to do. So when you're given the interior, you want to always subtract from 180 and get the exterior. So I'm going to give you a little problem here to try. And there's the easy way to do it, and there's the hard way to do it. For one, you can just try with anything. If you don't know what to do, you can tell me what this angle is here. Everybody in this room can tell me this angle. 90. Okay, but I would rather work with the exterior angles because it's easier. But you can do it with the interior if you'd like. So I'm going to give you a second to try that. I want to find this exterior angle. And I know one thing. The sum of the exterior angles has to add up to 360. I have this exterior one. I have this exterior one. I have this exterior one. I don't have that one. But I can find it. And now you'll want a calculator. Oh, yeah, that's not the batteries. So you're going to have to add them up. And yes, it gets really tedious without a calculator. So you want to use your calculator. Did you figure out what this one was? Because you got to add that one in. Don't forget that last one down by the 110. And you have a calculator. What is all that? Okay, so we want to be back here. Yeah. Slide that up. Oh, that's right. And what's true about the 70 plus the A plus the 86? Yeah. So you can do it. You just need a calculator. Now, just because you have a calculator doesn't mean you're going to get the right answer. You need to practice with a calculator. Because the sum of the exteriors, A plus 70 plus 90 plus 50 plus 86 equals 360. So you can do the interiors. It's just harder. Yes, but you can, but it's just harder. Yeah, let's do both. So, no, you didn't do it wrong. Okay. So Cole went, first let's do it the easy way. How big is this one? 70, right? So if I take 90 plus 50 plus 86, all the outside ones, plus A plus 70, these all have to add up to what? 360. Now, if you don't want to do that, if you want to do the interiors, you can. That's 90. How big is this one? 130. It's just a harder formula. Ooh, what's the next one? 94. I have a tough time with that. Getting better at it. And this isn't going to give me A. This is going to give me 180 minus A. So let's call it X. So if I add these up, 90 plus 130 plus 94 plus 110 plus X has to equal, now this is a pentagon, so it's going to be 5 minus 2 times 180. I had to use that formula. I can. Nothing wrong with it. What'd you get for X? What'd you get for A? I don't care. X is 64? Oh, I'm sorry. I'm looking at it funny. I didn't look. This is 116, and this is 64. Yeah, I was looking at it weird. Okay? So you see there's two ways to do it. If you have these formulas written down in front of you, I like to work with the exterior angles because it's easier. Okay, now I really want you to get involved on this one. This is a little chart, and we're going to find everything. Now what's missing on my chart is that this is only true for a regular polygon. So we better write it down. Regular polygon. Because I can't use 360 divided by n, or 360 over e, if it's not regular, because all the exterior angles are different. They all have to be the same. So this is given n, and let's write down the formulas here. What's s of I? At least that's how I attack the problem. What's the formula for the sum of the interior? Minus 2, excellent call, times 180. What's true about the interior and the exterior? These add up to, no, this is a linear pair, 180. Oh, and should we do the easy part first? What's S of E? 360. It's 360 on your whole chart. And then when I fill in what I know, I get a little more confidence. At first, it's a blank chart, and I'm going, I don't know what to do. But I can do that. So always do the easy stuff. You always want to get your points quickly. Sum of the exterior is always 360. And then I want to find the exterior angle. And the exterior angle, because it's regular, is going to be 360 divided by n. That should help. We'll do the first two together, and then I'm going to come back and walk around and let you guys do the other three. And then I'll come back to it. So this one's pretty straightforward. If n is 15, what's the sum of the interior angles? I do 15 minus 2 times 180, or 13 times 180. What does that give me? I have mine written down someplace. 23,000 something, isn't it? What is it? 23,040? 2340. Okay, couldn't remember what it was. That's the sum of the interiors. Is she right? Okay. How do you know? Yeah. You guys, how do you think engineers do it? They don't have any answers. I don't have any answers either, so I compare my answers with yours. Because I wasn't giving any answers. Okay. I need to get the exterior angle or the interior angle. It's easier to get the exterior angle because I'm going to take 360 and divide by how many sides I have. If that doesn't go evenly, then I don't have a polygon. How many times does that go? That's 24. Degrees. Let's put the degrees in there. Then how do you find the interior angle? Remember, the interior plus the exterior has to add to 180. So what are you going to do with 180 degrees and 24? Subtract them. So if you were sick today and you wanted to come back and look at this, my document, you can see how I got the answers, not just the answers. And when you study, the question came up in first hour, how do you study for a math test? Well, you cover up your answers here. You've got them all on Schoology. You can open up a new document, rework the problems. Can you do the problem? If you can't, if you've got good work here, you can go back and figure out what in the world you had to do. Well, what is that? 180 minus 24. 156? We take 360 degrees divided by 15 sides. It's this formula written, and I have it written in 3 different ways because it's useful for me. And that's why I wrote it down like that, because I want to keep that in front of me. Okay, so it's like a puzzle. On the next one, you know the measure of the interior angle. What's the easy one to get? If the interior angle is 120, you can find the exterior angle. How do we do that? It's 180 degrees minus 120. What's the exterior angle? 60. Okay, I still need to know how many sides. And I've got the formula here. The number of sides is 360 divided by the 60-degree angle. Does that make sense? Because the number of sides times the 60 equals 360. So the number of sides is equal to 360 over 60. What's n? 6. Called a hexagon. And by the way, after you've done a number of the ones, like between 3 and then 12, you're going to know them. You've seen them enough times, you're going to know them. So now what's the sum of the interior? You go n minus 2 times 180. There's my plan. And you can just pinch your screen to make it so it fits. So it's 4 times 180. We've done this one today, haven't we? 720. So you go and you figure out what you can figure out. I got the number of sides by taking the exterior angle. I don't work with the interiors. That's my last thing I'm going to do. Or maybe first thing here, because that's easy to do. So you got a couple to try, and I'm going to walk around and help you out. Okay, and you know what? I was a little incomplete on my chart. I had E equals 360 over N, and let's put this one. N equals 360 divided by the exterior angle. So the exterior angle is 8 degrees, so you take 360 divided by 8. What do we get? 45? Then this is 45 minus 2 times 180. Some of you don't have your little formulas written up there, and it's just a lot easier if you do. In fact, let's just put the 360 here, and then everything's complete. And then, we need to finish up on last night's assignment, and we can start on tonight's, maybe. Okay, so I don't know what that is. How do you find the interior angle? How did you do this? If the exterior angle is 8 degrees, the interior plus the exterior has to be 180. So you take 180 minus 8. I put the degree symbol, it's easier there. So how do you get the number of sides on this last one? A number of you had a question on that. Oh, this is n minus 2 times 180. I know how to do it. How do you do it? You do 2/8 like that divided by 180. And then add 2. Okay, here's the algebra equation. And because n is going to be a whole number, I know that 180 has to divide evenly into that. If it doesn't, I don't have a polygon. Because you can't have half a side, right? So how many times does 180 go into 2880? 280 goes to 180 goes in there like 4 times. Write it. It goes in there by 18 times. No, I think it's small. Times. Is that 16? Yeah. Oh, equals n minus 2. Then what's n? 18. Okay. So this is 18. I do the exterior angles because the exterior angle is 360 divided by n. That's the equation. N times E equals 360. That's where it comes from. So that's 360 divided by 18, which is how big? How many times does 18 go to 36? It's 20. And now can you get me the interior angle? Because I subtract this from 180. So I have all my work here so that when I save this, you can come back and look at it. Try it on your own. Cover it up. Open a new document and do it again, or make different numbers. Good. Not everybody was able to, though. Okay, ready to go on? No? There, all that chart's filled in for it. And then I save it. I export it to a PDF, so if you miss something, it's there. And it's all labeled. And then there's the video, too, that goes with this. This next slide is a flow proof. It's a proof that the sum of the exterior angles is 360. I just want you to get the feel for this. I'm not expecting mastery on this at all, because you've never seen this before. Okay, TJ? It says A plus B is 180. How do I know that? Great, Sydney. It forms a linear pair. Now, what this is actual proof that the sum of the angles adds up to 360. Okay, Manuel? What about C plus D? Exact same thing. We have to read it to make sure it's the exact same thing. How about E plus F? It's the same. It's a linear pair. Because anytime you make a statement, you have to give a reason for it. You use ditto marks or something, Or you can highlight it. I think if you just tap on it, you can copy it and paste. I think you can do that. Now, the author here gives us a little help. They said, let's add up A plus B. That's the first linear pair. Then they do the second linear pair. And they do the third linear pair. What does that add up to, TJ? I'm adding all the left sides, so guess what I have to do? I have to add all the right sides. How many 180s are there? It's 540 degrees because it's 3 times 180, right? Okay. Now, you guys, I have to figure out what they're doing next. Now, look at the picture. This is all the angles. These are all the angles. What are A C, and E. A, C, and E, what do they add up to? 180. Why? It's called the triangle sum. I would have said the sum of the angles of a triangle is 180, but we also call it triangle sum, so why not? It's shorter. And then what we're going to do is we're going to take this equation here and subtract it from that equation. So what's going to happen? When I subtract it, what's going to happen to the A's? They're going to be gone. I subtract the C's out, gone. I subtract the E's out. On the left side, I'm left with B, D, and F. And what am I going to end up on the right side? 540 minus 180. And what do I get? Surprise, surprise, 360. Now, I wouldn't expect you to be able to do this proof. We will be doing proofs later on. Right now, it's just the beginning of a proof. And that actually proves to you, no matter what these measures are, if it's regular or not, that the sum of the exterior angles is 360 for any polygon. And there's one more problem to do. I'm sorry, this is just a long lesson, but there it is. Let's try that one. And you're going to want to look for overlapping triangles, maybe. I think so. I'll give you a little hint here. I started with angle A. Because if you take this triangle, all those angles add up to 180. And again, I'm going to walk around and see how you do it. Okay, so you see how I'm going to do the triangle? I've just highlighted it right there. Some of the times you're going to want to use colors because it separates them out. And yeah, use a calculator. So I forgot what A was. Yeah, that's right. But B and A are the same. Why? B and A are going to be the same. Why? Yes. Okay, add these up. 61 plus 92 plus that is 180. So you're going to subtract. How come you don't have anything written down? Well, you have to pinch it, and then you can write on it. We're doing this one. And I would do this one. What's that? I would look at this triangle right there. Because that angle plus that angle plus that one is 180. Oh, Mr. U's not here. And if you're having problems with this, tomorrow we're just going to work on this. I'm going to go over questions on homework. But if you're having problems with it, I'm here in the morning, and I even have candy if you come in. Yeah? It won't help you in this problem, I don't think. You want to look at this triangle right here. Those angles add up to 180, so you can find A. You see? I'm going to use a color here. Everybody's got different colors. It's kind of cool. Those angles, those three have to add up to 180. You have to ignore, yeah, that's right. Good. You have to ignore the overlapping lines. That's right. A is 27. Let's find B. Nope. Nope. Not a right triangle. It doesn't look like one either. No, is yours dead? Okay, what did we get? We got 27. I did a spot check. Most of you got that, I think. Now, these lines are parallel. So what's true about B and A? They're the same. Do you remember what we call those? Interior. Alternate interior angles. Now, some of this, sophomores and juniors, if I have juniors in here, if you're taking the PSAT next week, which you are on Wednesday, you might be using some of this material on that exam. So, and it's also on the ACT. Okay, once we get B, I'm going to mark it here, it's 27. I can now find C. Why? Oh, let's use purple. Because this triangle adds up to 180. I think the homework is easier than the homework. So no more than 30 minutes, but do try and look at it tonight and make sure you understand. Maybe it's just watching the video and doing the notes again. Okay, so how much is C? Does everybody agree? I don't have my iPad open, so I don't know. And to find D is probably the tricky one. Anybody see how to find D? What am I going to do? I want the quadrilateral because those all add up to, we should know what the angles of a quadrilateral add up to. 360. And since C is 107, this is, well, I got to find this angle here. Okay, Zach? Yeah, it's 180 minus that. It's 73. So to get D, which is the hardest one, is 73 plus D plus 61 plus 92 has to add up to 360. And there it's clear that I know what I'm doing, even if I do my arithmetic wrong. And right now I want to be able to assess that. What did you get for D? 134? The next problem is a homework problem, and it is marked on your homework correctly. It's tricky to get the last piece. I won't give you the hint yet, but I'm going to tell you have to look for a big figure out of that, all those little figures. So if we want to look at lesson 3, I think I have a slide. Homework, those of you who tried it. Oh yeah, I do. I put it in a weird place. And so you're going to ask me questions on this, and we'll just go until we run out of time. So if you haven't done it, you may not have any questions. Or maybe you have questions because you have no idea how to do any of it. Now, one thing that I ran into yesterday was some people asking, I don't know which class it was, what does this little symbol mean? That means parallel. Well, now I'm telling you. And you know, you guys can always email me and say, hey, I don't know what that little symbol means. I'll email you back. And what I did in the last class is I said I want ZO parallel to ID. So I did this. Okay, you guys, pay attention. Now, Sydney, is that right? Read it carefully. It's trapezoid zoid. So it should go ZOID. Now it's correct. So you need to check. And there's like 30 of you in here, and there's 34 in my other class. I can't be grading every single problem. I can try, but I don't have enough time to do that. You have to be responsible and check what you did to see if it's right. Same with these. I don't know if there's other questions on that. Your homework looked pretty good. Number you skipped number 18. And the problem with 18 is when you draw this, you have one at 0, 0, one at 4, 2, and that's the side of your square, so you want it this way. I would put it on graph paper. It's not going to be sitting on the x-axis or the y-axis. And those look pretty good, by the way. Okay, how about problem 1? Are we okay with this one? This is the n minus 2 times 180. And then this says we have an equiangular hexagon or equiangular polygon. So you take the sum of the interior angles and you divide by n. Okay, I'm looking for questions on any of these. The top one is n minus 2 times 180, and this is s of I divided by n. So if you didn't do your homework tonight, last night, you've got a little bit of extra work to do. You should get this assignment done. Give it a try on the last couple problems to finish this up, and you can get started on the other one. You're right. I haven't given it to you. Good point. You will. Yeah, you will. I just have to figure out what I do with them. Oh. Yes?